have our final presenter today.
Yes, so I'm Celina. I now work for Texas A&M AgriLife Extension Service. I'm an extension program specialist on the Green Infrastructure for Texas team. So we are part of a unit called Disaster Assessment and Recovery. Some of you may have already known about AgriLife Extension. Maybe you've been to your local county office, or you've heard about or participated in 4-H. A lot of times when we say our agency name, people don't recognize us, but they recognize those programs like Master Gardeners, Master Naturalists. So our Green Infrastructure for Texas team is not tied to a county office, though we try to work closely with them. We're in the Clear Lake area. We're between Houston and Galveston off 45, just real close to EIH still. And we work up and down the coast and occasionally further inland. So one of the main things that we do is provide education and outreach to local governments as well as citizens on the impacts of land use decisions for communities, mainly water quality. So, a lot of the stuff you've been hearing today, what we do in our everyday actions, the decisions our communities make as we continue to grow, we're changing the landscape. We're changing the way the water moves over the land. So, I am going to talk about water, but I've been listening closely. So, hopefully, not too much overlap other than to support some of the information you've already heard. So, on most days, many of us are not thinking about water unless you're super into fishing, you teach science. We see it all the time, but we don't always give it that place kind of in our day. It's really when it starts to look like this, or we don't receive a lot of rain, that people get really concerned and they start talking more about our water resources. So, in our office, we really want to encourage people to think about both of these scenarios as we're planning our landscapes as our communities are continuing to grow. So, we can get a lot of rainfall, a little amount of rainfall. This can be too much for our needs, but also it can wreak havoc on our surrounding wildlife and our habitats. So, it's important for us to think about what we do on our properties. We can do things like incorporate green infrastructure to help just our yard as well as the larger community. And people have talked before about picking plants. We want to pick plants that are adapted here that can handle local weather conditions and our local soils. So, our water challenges aren't just about pollution and water quality, although that's definitely the focus of the day, and that's focus of our office as well. I'm going to bring up some of those water conservation concerns that Dr. Garland had earlier. So, it's about having too much water, too little water, the quantity, as well as how fast it's moving across our landscape. So, this is where green infrastructure can come in and start to help us make a difference. So I'm going to highlight the State Water Plan by the Texas Water Development Board. This is something that they issue every 5 years. This is a future-looking document. They're showing our current needs, our future water needs over the state for the next 50 years. And I know, again, Dr. Garland had mentioned water needs and this issue kind of on a nationwide complex and even globally. So I'm just going to bring it really a little bit more hyper-local and give you some numbers for us in our region. If you look at the table at the top, this shows how much water is currently used. And when I say current, I mean 2020, that 2020 column toward the left, as well as over the next 50 years. And it's broken down into category. I want to draw your attention over to the column on the very right, and that is going to be percent change. That is how much additional water we're expected to need. And you can see that the biggest increase is in the municipal category. That's a 1,300% increase. I know it's over a long period of time, but time does continue to move forward. So it's important to look at that. So Kathleen dove into those municipal uses earlier, talked about brushing our teeth, washing our dishes, and there's a big opportunity for water conservation here. I want to also point out the outdoor water usage, and that's been mentioned a little bit. So, how often are we sinking a large amount of resources into creating super clean water that we can drink just to dump it onto the ground? It sounds really extreme, and some people they've never thought about it before, but that's what we're doing. That's what we're doing when we are irrigating and watering our lawns. Unless, like that at UH Clear Lake, they have water reuse there. There's other entities, surely, that are using gray water and reusing it in that way. But for the most part, especially at our homes, that's not what we're doing. So practices like collecting and reusing rainwater, choosing those native and adapted plants, that's going to require less water And it gets us thinking about our water supply a little bit differently so that we can look at it as a whole and kind of reduce our need for that clean water for every single thing we do. So, another plan this same agency is starting to bring out, this was the first release in 2024. This is on flooding. This is also going to be updated every 5 years. That's the plan. And it contains projects that can be undertaken to reduce the flood risk for our Texas residents. So the map that you're looking at is from the flood plan, and it does highlight some flood prone areas toward the coast. But I guess, I just want to point out the big blue areas all over the state. These are our flood hazard areas. So we see flooding everywhere in Texas, and localized flooding from stormwater, from just rain events, that's not accounted for here. So no matter where you're located, it's possible that in the last 10 years, you've probably either experienced flooding or you've been close to someone who has. Another benefit of green infrastructure that we're going to talk about and how to protect our communities from flooding is to leave space for water. Water flows through bayous and streams, and when they're left natural and they have a sufficient buffer and vegetation around them, they can take on a lot for us and they provide a lot of benefit in that way. So, leaving room for water and watching where we develop is also something very important to think about. And green infrastructure on a large scale, protecting those natural areas, that's going to help us plan better in the future and mitigate for some of these hazards. So I mentioned that we're part of disaster assessment and recovery. We're on the mitigation side. So they like to call us their blue skies branch. We're not running out during a flood event. We're not helping with recovery. Our little team are. We do have agents that work closely with us, but we do mitigation. So, you know, our team and Extension Surface, we're an education agency. So we are trying to connect the university to the public. We want to bring research-based, science-based information to Texans in a way that's accessible and useful. Our team does that through educational events. We do webinars like this. We do our own half full day green infrastructure workshops as well, field days. We work with communities directly to install on the ground projects. And we can also do applied research on green infrastructure because we want to make sure that after they're installed, they're evaluated and that we're continuing to recommend best practices that are actually working. So it's really important to revisit these sites. And our team really likes to talk about green infrastructure at different scales. So these practices, there is many of them. They can be on a single developed piece of property, like a house, a small business, or just a business in general. Practices can be suited for a whole neighborhood or a smaller community. That's that mid-scale level. So now we're serving multiple people. And then we can go all the way up to large scale. This is the preservation and the restoration and the conservation of natural areas because they can provide a multitude of services and we want to keep those intact. So, what is green infrastructure? I've said it a lot of times, but I haven't really defined it yet. So, this is an approach to land development, even redevelopment, that works with nature to manage stormwater as close to a source as possible. And I think that's really key. Historically, and even now, we see that a lot of people want the water gone. They want it gone fast and they want to make it move. And so we're trying to start the conversation back up around the benefits of keeping water on site like it was before development. So this can be used as a complement to that gray infrastructure that moves the water fast, the concrete that we're so used to seeing. So what should we call it? You may have heard of nature-based solutions, low impact development. We use green stormwater infrastructure a lot, and we're hearing more and more people refer to this as blue-green infrastructure. I get a little sad because I feel like the soil is left out of that one. So I want to add brown, but I don't think that that's going to gain popularity. But these are really just best management practices for stormwater. And I know that Jenny mentioned, there's a lot of different programmatic where it's maybe not on the ground, but there's all these behaviors and practices we can do as individuals. So these are the on the ground best management practices. And for us, it's not really about the label, it's the approach, how these things function, and how they can be applied in our communities. Okay, so I think this is a little bit different, get into detail on a different aspect that we haven't heard today. This is a hydrograph. This is not a highly scientific graph. It's really meant to be more picture. But the x-axis, which is on the bottom, is our time. and the y-axis is the flow rate. And we're going to look at water moving across the land, and we're thinking about when it rains. So the picture in the back is a native prairie. This is the restored prairie at Armand Bayou Nature Center. This is actually right down the street from EIH, but we have native prairies up and down the coast. So when it first starts to rain, most of the water in this kind of system is going to soak in. It's going to go down to the roots of the plants, go into the soil. Maybe some of it evaporates off the leaves. But as the intensity of the storm picks up, even in these natural systems, there's a little bit of runoff, so you can kind of see that line come up. The storm continues, there's less and less runoff because it's decreasing again, and overall, this flow is going away. So what happens when we change the system? We're going to look at, I guess, a big box store of some sort, and instead of having prairie to soak into, now we have an impervious roof, we have impervious parking lot, we have a tiny little tree and little grass, which I think was intended to do something here. But what happens to it now when it rains? So almost immediately, we're going to see the runoff happen. The water cannot soak into the ground. The peak is a lot higher here, so we're going to see more runoff, and we're going to see it arrive a lot faster to neighboring properties. So now we're shedding this off, and we're causing issues for other people. So the idea is that we want to use nature-based solutions to get that red line of the developed properties as close to that black line as possible. So we want to retrofit. We want to add different practices to try to mimic that black line of nature. As biologists and environmental scientists, we don't really believe we're going to hit it. Some engineers tell us that they can, but what we really want to do is just get it down closer. We want to help the big picture in the long run. So the way that we do that is with green infrastructure. We want to slow the water down, spread it out, let it soak in. In the case of a rain barrel, it'd be a little different. You're just holding it in there, waiting until after it rains, and then releasing stuff to water plants at another time. And what we want to do is reduce that amount of water that's going downstream. And that's going to bring water quality improvements and relief for our local drainage systems. So they've covered this already. Stormwater it goes into the drain, it goes to the stream. But a lot of people, they really haven't thought about this. This connection gets lost. You'd be surprised how many people we interact with that really think there's a treatment plant there. They really think that the city's taking care of it. That storm drain looks really professional. They think it's going somewhere. But the water is not treated. It picks up everything that is present along the way and it takes it. So we're changing the picture a little bit here. Instead of the water going straight from the lawn to the street, we're going to inject a stormwater practice, a green practice. So in this case, this is a rain garden. This is in League City at the Girardi Water Smart Park. So in this case, the soil and the vegetation can create a natural filter and it can act like a treatment plant. So look at us. We're retaining it for a short period of time, soaking some of it in. Microbes in the soil are breaking down pollutants like some of the hydrocarbons from the parking lot, from the cars, maybe some nitrogen and phosphorus if they're using any kind of nutrients there on the lawn areas. And then water can continue downstream a little cleaner. The practices we're going to kind of show you examples of, they're also going to give you a lot of other benefits. This is not just water quality or flood control. So when we start using native plants, like has been said before, we're going to create some habitat. And depending on where we are and how big these things are, if they're small, maybe it's just habitat for songbirds, butterflies, hummingbirds. But these practices also create beauty, aesthetics. That picture on the top left is at a library in Galveston County, just south of Houston. So when we're talking about ways to reduce stormwater and somebody installs a rain garden instead of maybe a big concrete culvert, that's a lot different of an experience outside of your library window. We've seen libraries, for example, one in Robstown, they have installed a rain garden recently through partnerships, and they had books on green infrastructure. They made little resource guides, and they have been taking classes out there too. So the local community library has used the rain garden now as an education, so it can serve multiple benefits. A lot of these are flexible. You know, we want to see what's needed at the site, and we want to see what's possible. They can be incorporated into the existing community, basically. It doesn't have to be a new project. If something else is already being improved on site, maybe there's room to incorporate one of these systems. So I have to take a minute for soil because I have a newfound love for soil and I've been doing some soil programming with how it relates to green infrastructure. And it's really overlooked a lot with these green infrastructure discussions, but the plants need that soil, and the soil is also providing the benefits. So organic matter, just as a reminder, is the plants and animal material that's decomposing in the soil. And this helps regulate the temperature, which can support the life that's inside the soil. It also helps that soil act as a sponge. So the soil's working really hard under there. And so for a visual, we put an acre piece of property, we used a football field there, and just to start the conversation of if we increased organic matter by 1% through composting, how many more gallons of water do we think that soil can hold? The top 6 inches of soil. And the answer is 25,000 gallons-ish, depending. So that's pretty significant. We're talking about water holding on site and not running off. And when cities see this and communities see this, it means a lot to them. And where they thought maybe before composting is not for them, they begin to open up a little bit, and hopefully we can make some progress in that area on a large scale. Just a couple more of these. So when impervious cover in a community reaches around 10% of the watershed, they showed a lot of watershed maps earlier, we start to see stream channels beginning to erode. When that impervious cover, and again, we're talking about roofs and streets and everything we need in our communities to drive that sort of thing, when they exceed 25%, the channel erosion and the habitat degradation become significant. So it's just a little here. If you're looking at a map of the entire community, this is the percent where we start to see some detriment. So we want to break that up. We want to disconnect the downspouts. We want to catch the rainwater. We want to allow for more nature to be in our communities. So one more fun fact. I think it's a fun fact. I hope you do too. And I have sources for all these if you guys end up wanting specifics. This is giving us an idea if you happen to have an acre yard or you know somebody that does and you can picture that in your mind. Again, that picture we showed earlier. During just a 1-inch rainfall, this is a very small rainfall, the amount of gallons that fall onto that yard during that 1-inch rainfall is 27,000 gallons. Again, so like if your lawn has more organics in it or you have less lawn and more native plants like it sounds windy does, you're keeping that on site and you're doing a service for everyone, for nature, but also for the community. Okay, so we've talked a lot about what green infrastructure does. Now we're going to start getting into the actual projects. Man, this was really hard. So I really wanted to share so much with you guys, but I had to pick just a couple because it's a talk to cover all the things. So we're organizing the talk around scale. Scale is really important for the productivity and function of an ecosystem. And since I'm starting with large scales, we're really going to talk about ecosystem services for a second. Site and mid-scale projects offer a lot of benefits, but they cannot offer the number that these large-scale lands can do, on their own. So if you are listening at this point and thinking, man, Celina, I don't have any large landscapes to manage and I don't know that this applies to me, you're going to see that some of these projects took place over time with little smaller efforts. And I'm going to hopefully remember, I have it in my talk to share with you some of the ways that you can advocate for things like this that you see so that we can maybe get some more projects like this. But what we're doing is we're acknowledging prairies and forests and wetlands and any large undisturbed land. We're acknowledging them for the green infrastructure that they are, and we're keeping them in place because there's no engineering required here. It's already benefiting us. All right, so large scale. We're going to talk more about protecting and conservation here in a second, but the lower left picture that's from the case study I'm going to go into. That's the Sheldon Lake State Park Prairie Wetland Complex. Second picture from the left is showing a vegetative buffer in an agricultural context. So just showing that we can provide filtration with just not mowing and not grazing properties around our streams. That includes, providing another water source for animals and keeping them and their bacteria out. And in the hill country, there's some amazing work done. In San Antonio, city of San Antonio, a lot of residents are opting for their sales taxes to be used to buy property outside of city limits. Because for years they have been educating people and finding that if they keep these lands protected, they are protecting their water resources for the city. So the city uses their drinking water is coming from groundwater, and that is being replenished through the soil and through the rock formations underground. And it's very sensitive and it doesn't really receive a lot of filtration. So they're keeping the land safe. And that's a really good case study, too, that I don't have time to go into. So I'm going to breeze through these ecosystem services. This can help communicate the why. If you guys are trying to communicate to your students, or if you want to work with your school to do something like this, or even if you get involved in something in your community, this is a good way to illustrate to people who are funding, to people who are partnering, why these things are important. Because, like I said with the water, not everybody is thinking about these things every day. So, healthy natural areas are providing services for us. These are the most foundational processes that support all life. Dr. Garland got into this. This is the rainforest as the lungs of our planet. This is our wetlands that are right here in the Gulf Coast that are helping detain storm water for us and keeping us safe from storms. So there's stuff that we haven't thought about in a long time, but I'd say you guys are teachers, so I don't know what your curriculum is. You may already be doing this in your stuff. So, provisioning services. Ecosystems provide clean water for us. They provide food. The fishing industry is very much alive. There's berries in other parts of the United States. There's medicines that we get from our ecosystems and raw materials. Regulating services are a benefit provided by these ecosystems where they moderate processes that are natural. So basically, floodwater detention, carbon storage, and climate regulation, purification of water and air, decomposition of waste, and pollination. This is stuff that's being provided for us for free. We also have cultural services that are non material. We have just appreciating natural beauty of open space. We can connect spiritually in these natural areas. There's a lot of recreation opportunities, so hiking and bird watching and fishing, and there's education when we go into nature. Healthy ecosystems also provide everything that native species need to survive and thrive. These are the supporting services. So things like photosynthesis, habitat, biodiversity, and soil formation. The benefits that we gain from those are oxygen produced during photosynthesis in plants and healthy soils, which are the basis of our agriculture. So when these ecosystem services are lost, they often need to be replaced. They can either cost a lot of money, or maybe we don't know how to replace them yet and they are irreplaceable. An example of this is when we pave over wetlands or prairies, that can result in lost stormwater detention. So afterward, the community is having to do something to make up for that. They need to excavate detention or build other infrastructure to avoid that additional flooding. So these can be hard to quantify. There are numbers out there. But again, this is really meant to be an example of a tool that can be used when communicating and advocating for projects. So how can we manage land and promote all of these ecosystem services and ensure all of those mechanisms they're providing for us so that they can continue to act the way they do, so that they can withstand disturbance and remain resilient? And when it comes to large lands, there's three general approaches for designing these projects. They're often used interchangeably, but there's some subtle differences. So over 100 years ago, there were two contrasting views for how to manage America's lands. Both are working to protect the open space, but conservationists, which is that first category, they wanted to regulate human use. And preservationists aimed to eliminate, take it all away, the human impact. So our natural forest, or an example of conservation, land is used for recreation there by the general public. Sometimes industry and logging can use it at some capacity. But preservation is when you want to keep something as it is. Maybe you keep humans out completely or severely limit their use. And then we have restoration, which is bringing a piece of property back from its degraded state. So Sheldon Lake State Park is northeast Houston. There's a lot of people within close proximity. They may not realize that this big piece of property provides them with a lot of benefit. It holds a lot of water. There was a turf grass operation that was there. And for this restoration project many years ago, our office was part of the team that restored the wetland there. So this particular restoration took about 15 years. It had 5 phases. This is just one phase that we're showing here, and it covers 410 acres. Our office really was interested in putting the wetlands back as close to the original location as possible. The whole team worked together to look at historic extent. They digitized topographic maps. This was many years ago. They looked at soil maps from NRCS, aerial photography, just to really find where the wetlands were and how that elevation was changed so that they could mimic it as much as possible. And when they got into it, they actively planted instead of just letting, excavating and let it come back. They took some time. Lots of volunteers came together over the years, and they got plants from within 50 miles of the site. Again, we want plants that can make it here. Looks a little scary there in that upper left picture. A lot of volunteers were skeptical. There wasn't rain at that time, it was very dry, but the rain came and the ponds filled and nature filled in the gaps. There was also remnant seeds there from historic wetlands that were present. And so now this wetland area can hold water safely and help keep businesses and homes nearby safe from flooding. This is shown to illustrate these 5 phases that evolved over time. This happened as funding became available, as new partners entered the picture. It started out as a 10-acre wetland that was closer to a mid-scale effort, and it grew over time. The project also experienced a disturbance. In 2011, there was a major drought, and the native plants looked pretty terrible for a little while, but it proved that native, locally collected plants were well adapted, and they made it. They were fine. Okay, quick view of another example. This is utility easements. So I don't know if you've ever looked at utility easements where power lines are or pipelines and thought that something could be done differently there, but those corridors are being transformed by utilities into green infrastructure. There's a Texas Native Seeds program. It's out of the Caesar Kleberg Wildlife Research Institute through Texas A&M down south of here, and this project was in Kennedy County. They've worked with industry partners over the last 20 years, but this particular project, they took monarch butterfly friendly seed mixes and they planted a 42-mile section of this pipeline. It was a lot of landowners. It was the King Ranch, it was Enbridge Energy, and that Wildlife Research Institute. Here in our Houston region, Houston Wilderness has a similar initiative. It's the Southeast Texas Native Seed Mix Initiative, and they support projects like this one. So, where you don't have large properties to set aside, you can look at connecting smaller scale projects into a larger network. So this is showing a few different ideas. You have an actual like a river or bayou corridor. You can do something along that. We connect these green spaces along the streets and through parks. And so it's just keeping an open mind and looking for opportunities. Okay, mid-scale. So now we're going to go down a little bit smaller. We're going to look more at the neighborhood level. And the left is a stormwater wetland at Houston Botanic Garden. The middle photo is again kind of a riparian buffer, just on a smaller scale. That's that agricultural practice we highlighted earlier. And then we have a living shoreline on the right that Galveston Bay Foundation did a few years ago. All right, one of the biggest projects that gets highlighted a lot is Exploration Green, and I think you'll see why after I go over it. This is a stormwater wetland project, and these are created or engineered wetlands. They're not natural. They take water from maybe 25 to 500 acres. This is about the size of them. In this case, we have a 5-phase project. Again, it was done little over a time, and it covers 200 acres. Each of the phases can retain about 100 million gallons of stormwater. So together, they equal 500 million gallons. Excavation, digging out these basins, was completed in 2024, but phase 5 is still being planted with trees and with additional wetland plants. This location is home to over 1,000 species of plants and animals, and the partners continue to have programming for school groups, for field trips. There's a lot of opportunity here for teaching. It's also where we have our plant nursery for our wetland team. So this is a great example of a community coming together. This was actually an old golf course that was no longer being used and wasn't profitable. Clear Lake City Water Authority acquired the land through eminent domain, and they are also connected with Galveston Bay Foundation for holding the easement. This is all about homeowner involvement. This became kind of complicated. Homeowners wanted more amenities and not just an ugly hole in the ground with water and a fence around it. But they also had a lot of concerns like mosquitoes and stuff. So there was a lot of meetings that it took to, and a lot of years that it took to get this off the ground. But this is one of the things that accelerated the construction timeline. So during Harvey, which is the picture on the right, a lot of water got held in these, whatever the completed phases were at the time in this practice. Previously, 150 homes in this neighborhood had been flooded from different events, and there were none flooded during Harvey. And the homeowners noticed, and they got a sense of urgency in completing the entire project. And so they sped up the timeline and they pushed for more funding. And so this is, like I said, a lot of people like to highlight it. Don't have time to dive into really multiple projects on each scale, but I did want to mention that hospital complexes are also doing stormwater wetlands. The middle photo here is kind of the before, the right photo is after. Those both are the same site. And this is basically a year apart. The hospital was expanding a parking lot and they incorporated a stormwater wetland. So this can happen in a variety of different ways. It can happen at schools too. ISDs can employ some of these practices and have. So now we're down to site scale. Okay, now we're looking at stuff that's more familiar that maybe GBF and HGAC had mentioned, stuff like rainwater harvesting, rain gardens, permeable pavement, and green roofs. And these are all sites really close to the Clear Lake area, Webster, Pasadena, League City. All right, so I'm going to highlight one of our newer projects. This was done in the city of Hitchcock, which is in Galveston County. A lot of people mentioned watershed protection plans earlier. From a watershed protection plan and years of engaging with the city, they weren't coming to meetings, but through an outside conversation, we started talking about green infrastructure. We'll work together to apply for a grant, and it took a couple of years. Now, if you had a contractor and a lot of money, this could have been done, I don't know, in 3 months, but it took us over 2 years to do this because of how the funding is, you know. But it takes time to build rapport and build the relationships to apply the funding to get the construction approval. And I want to point out the thing that I think that's unique, maybe not unique, I don't know. What I want to highlight about this project is that not all communities have capacity and budget and staff to take care of these things, and that's why you're not seeing them everywhere. This particular community doesn't have a parks department. Their streets and drainage guys are going to be the ones, when they can, weeding these things or trying to take care of them. And so we are going to reach out to the master naturalists in the area, have a couple of volunteer days of our own. But we did things like putting rocks on the edges and putting rocks around the entire border of these because we want to make it really easy to see and easier to maintain. We don't want these things to get mowed over. We don't want them to get forgotten about. So I think that's kind of the highlights there. I also wanted to remind that these are functional. We have people come to us and say, I want to put a rain garden in a spot, but it's an elevated spot. Now, rain gardens, let me go back to that picture, they're not a raised garden bed like you use at home. They're depressions in the ground that are meant to receive and hold water for a short amount of time. And so there needs to be water, you know? So you'd walk around and look where water is already pooling. And so that's what we did to choose the spots for this project. We had options to do multiple. We wanted to do permeable pavement. We wanted to do so many different things. But the city has some concepts to improve these parks over time. And so what we did was focus our efforts on installing these outside of the planned improvements because the timelines didn't coincide. We thought we'd be doing construction with them, but we ended up doing construction before they were ready to improve their parks. So again, with placement and trying to figure out where to put these things, if you're looking left to right at the top, we have kind of a planning or an urban planning type figure that shows rural or more farm or natural areas. And as you move to the right, you're getting a little bit more people and you're moving basically into downtown Houston here. And so the dark green is showing you where these practices are best applied. And good housekeeping is at the top everywhere. Natasha talked about litter, you know, just picking up trash and keeping it off the ground. That's a practice. That's a best management practice. The lighter green and the white is where maybe the project doesn't make a lot of sense. So if you take green roofs, for example, if you have a natural area that you, a forest or, you know, just a parkland, you have a lot of green already. You're not going to tear up a natural space to put in something like a green roof. That's really going to be more conducive to your more developed and more dense areas. Resilience. So, resilience is a word that was originally an ecological term for the environment. I see it all the time now being used, and same with the word watershed. There's watershed counseling services, there's watershed, but you guys learned what a watershed is earlier. This is just to share that everything that we do, we try to think about disturbances and we try to think about how to keep landscapes and communities more resilient. So, we apply ecological principles to our projects, like using native plants, putting things back where they naturally were. We want to refine our methods. We want to acknowledge where we don't know, and we bring in experts when we need to. And we're just, all of this is moving toward improving the safety and health of communities. You've already seen this map several times. All I wanted to do is say that some of these plans have green infrastructure efforts in them. And this can be opportunities for field trips if they're completed sites. And I wanted to have a reminder here that if you see things like this in your community and you end up taking your students and you're enjoying them, try to contact an elected official or a city or county staff. Let them know that you appreciate these types of projects. They don't often hear positive feedback from people, and I think that means a lot, and it does a lot toward moving toward future projects. These are the online resources I kind of handpicked to show you guys. There's many, many more. From our office, we have developed something called a quick look. That's the pervious pavement example. This is a one-page document. It's just a definition of each practice, and it has a bunch of pictures that are local to Texas. We found that when we would have meetings and we would just be introducing these ideas to people, they really wanted to see that it could be done here. That's very important for our local officials and communities, but also they don't want to be overloaded with a lot of information. So those are kind of nice, just one pagers that we use a lot in our work, and so we put them online. The other thing is we have some case studies. Again, all projects in Texas, these are other people's projects that we want to highlight around the state, and we have some elementary schools and stuff like that. HGAC, whom Jenny is from, they have undertaken low impact development programming for a very long time. And we've worked alongside them as well, and just hopefully just supporting each other and spreading the word about this stuff. Their website has a map with a lot of project sites, and they have this lovely Designing for Impact guide. It has more case studies from our region and goes into more detail about some of these projects. I'm not great on virtual, y'all. I really want to know, is anybody doing watershed stuff like this? Does anybody have Enviroscape model? Are y'all doing this stuff?
Well, I teach AP environmental science and environmental systems, and we do that create your own watershed, like with paper and models. So we do that in class.
Okay, nice. So we have one. Anyone else?
We do the model my watershed, but then I do kind of a simulation with just take paper and crumple it up and use different markers as dyes. And then we trace those dyes and kind of model the watershed at the same time and watch them move. So it's a real quick one, but then we go into the model my watershed with higher detail.
Nice. So the reason I'm asking is because you may not have ever thought, and maybe it doesn't make sense, but if you want to incorporate green infrastructure into that talk, if you have like more of a model setup, I don't know how it would work with the crumpled paper. You could just talk about it verbally. You can use sponges on those models to show how a wetland could soak up pollutants, to show best management practices of there's ways to stop these. And so you may already be doing stuff like that. It's just I know sometimes I focus a lot more on watersheds, and then I don't get into the BMPs for lack of time or whatever else. So I wanted to point that out if you didn't already know. And that Enviroscape, they have a free guide online that includes some of these activities. And again, you guys are the teachers, so I might be I might be telling you things that you already know. There's organizations in the area that loan these things out also, and then it sounds like you guys are doing some DIY stuff. So in order to build awareness on these issues and try to help the future workforce, they talked about a need with landscapers, stuff like that. We're trying to get the word out to high school students, and we are developing their knowledge base in green infrastructure. Since y'all are getting the slides later, I don't want to linger here because I see where I'm at with time. But our office is in Clear Lake. For school districts that are close, we take high school interns, and we are recruiting right now for that. This is some of the outcomes of our group. We're grant funded. It's on and off, but luckily we've got some funding to keep this thing going. Galveston Bay Foundation allows us to come to their site and see some of their practices. And so we do those field trips in the area. So this is just a reminder that ecosystems provide irreplaceable benefits. People are trying to mimic nature, but we really want to keep some of these things intact, and that they can be small, they can be super small, they can be at your school. That's pretty much it for me. Just wanted to say, I guess, thank you for the opportunity to share more on some of these projects. It was really hard to limit the case studies, but I hope it was helpful.
One quick question. You had the little quiz that you were doing guess the answer on that. What was the one about the percentage of impervious surfaces that have the impact? What was that percentage answer?
10% is really where you start to see unimpact. So you start to see erosion of the streams, I believe, is what I have down for that. Yeah, stream channels begin to erode. And I have an EPA source for that if you end up wanting it.
Thank you.
When you're talking about scale and timelines, you mentioned there were some site scales that could have taken 2 months, but it took 2 years. Like, does that also relate to the bigger scales, like the landscape level? Like sometimes you think a project's going to take 50, 10 years, but with money and the right contractor, it takes, or no, those like scale and time are always go hand in hand.
So, since these are natural practices, I think it's important to acknowledge that when you're dealing with plants and you're establishing things, that is going to take time. So, when I was emphasizing that, I guess, frustration with how long it took, we knew it was going to take that long because of the funding source. We knew that we had to go through certain steps with a designer and to get approval from our federal funding agency to start construction even after everything was done. We also were engaging the city and their preferences for what practices they wanted to see and to get buy-in from city council. So we got an MOU with the city and we presented to them. And so again, if you're, I don't know, I imagine school districts have similar like purchasing and getting approvals and this is where the time came in. If you were a private business and wanted to do it, that's where you could do it in 3 months if you had the money. But I think involving partners with experience, you brought up large scale specifically. I think that's important. I think that can help a lot.
But you mentioned MOU. What is that?
Oh, a MOU. A MOU is a memorandum of understanding between two parties. So in our case as a university, when we're going to work with a city, it's not that we're required by the grant or by even our agency to get that, but it's just a written agreement that outlines some of the things, the expectations we have. So like we are going to bring in grant funding and we want the city to participate by providing equipment and their staff time. And so it just puts it in writing and allows for smoother communication moving forward.
Do you offer some education for homeowners that may be interested but do not know where to find grant money or things to help pay for these things, like a rancher? Like, let's say they want to make these types of fencings or movable water sources, but they just don't know where to get the money.
So, I do work for AgriLife. My audience is not in the agricultural sector, which is, I know it seems silly. We do a lot of urban work, but we work closely with partners like the Texas State Soil and Water Conservation Board. They have local offices and programs for funding for landowners for those types of practices, as well as the NRCS or Natural Resource Conservation Service. They have local offices. Those agencies have funding programs. And then, of course, the AgriLife County office, ag agent. And so, yeah, I can help track that kind of stuff down and find the person for sure. That's kind of one of my super strengths, I think, is connecting the people. But I don't necessarily do that type of project.
So is that something you think you need some help with, Andrew? Finding somebody in your area?
Yeah, and then when we try to do like projects and things, sometimes it's the space, sometimes it's finding the right people to get us funding for certain things. And that's always personally, teachers can write grants, and I don't know where to send it or what, because you have teachers pay teachers and things like that. But I was wondering if there's another like level where I could say, okay, in my area, who would help support like a rain garden in my campus, or who would help me maintain it? Would I have to educate my groundskeepers, or like do I have to find my head groundskeeper and have him on board with the program as well?
If I'm answering that, I think that is the best way involving your groundskeeper from the beginning. With that city project, we incorporated a maintenance guide and we incorporated maintenance trainings. And there's always turnover. So even if you have somebody that's on board when you first start that project, I know Wendy can speak to this too. Over the years, as facilities changes, there may not be the interest, and it really may fall on. A lot of times it falls on volunteers, student groups, stuff like that, unless the city has parks with dedicated staff. And even then, they require continued training, like they were talking about earlier with landscapers not knowing certain things. And as far as funding for teachers, though, that's something I'd have to think on a little bit more. I'm a little outside of that, but my colleague works a lot more with teachers than I do. So
Thank you, Celina.